Now we are going to start the module 3 of third topic, which is again very important to solve or to find the least square solution of given any equation. Generally, you will be having one equation with one variable, and you need to find the least square solution, which is very much popularly used optimized algorithm, so that we can find the least solution of given any equation in one variable. The Python programming, with the help of SciPy, he can find the least square solution of given any equation. Now let us consider we need to find the least square solution for given equation y equals to 2 into x minus 3 whole square plus 1. When you see this equation y equals to 2 into x minus 3 whole square plus 1, you will find it is nothing but a quadratic equation because the power of x will be 2. Now, how we can find the least square solution of given this equation? How we can analyze the least square solution of given an equation? The question concept first we need to find. Let us consider any student who wants to learn what is least square and why we are bothering about it. If any student says, "Sir, I did not understand what do you mean, why we want to find least square solution? What is it?" Then for them, I just wanted to say, like, if you have given some, let us consider you have some input x1 and the input is c1. Let us consider that you have the input of x is equal to x1 and some value of coefficient that is nothing but c1. So similarly, you have some input x2 with coefficient c2. Similarly, some coefficient c10 with the value of x10. That means you want to find the equation. Let us consider y equation first x1 some values mixing with some coefficient c1. So x1 c1 is nothing but, let us consider y1. x2 c2 is nothing but y2, x3 c3 nothing but y3, and so on. If you have, let us consider x10 c10, you will be getting y10. So finally you are multiplying with the coefficients of the known values and you are adding all. So what output you will get? You will get x1 c1 plus x2 c2 plus x3 c3 plus x10 c10 and so on. Now what will be the actually the output, and what you will get? y1 because of x1 c1, y2 because of x2 c2, y10 because of x10 c10. Now the question is very simple. I should add y1 plus y2 plus y10 and x1 c1 plus x2 c2 plus x10 c10, and both should be equal. That means if I am adding three coefficients with the variables x1 c1 equals to y2, c2 equals to y2, and x3 c3 equals to y3, in that case what will be happening? y1 minus y1 plus y y3, y1 plus y2 plus y3 minus xc1 minus x2 c2 minus x3 c3 should be equals to approximately 0, because y1 is your x, getting y1 because of logically y1 plus y2 plus y3 minus x1 c1 minus x2 c2 minus x3 c3 should be equals to approximately 0, but practically or realistically it is not be equals to 0. Then student will ask, where we went wrong? We are getting y1 from x1 c1, y2 from x2 c2, y3 from x3 c3, and we are adding the outputs and we are adding the inputs multiplied with the coefficients. Then it should be approximately 0, but practically it will not happen like that. That means they reach some loss. They reach some loss, and that we need to meet it minimum as much as possible. That means approximately y1 plus y2 plus y3 minus x1 c1 minus x2 c2 minus x3 c3 should be equals to 0 logically, because y1 is nothing but x1 c1. y1 is not equals to, I'm telling y1 we obtained from x1 c1. y2 we obtained from x2 c2. y3 we obtained from x3 c3. But it does not mean that y1 equals to x1 c1, y2 equals to x3 c2, y3 equals to x3 c3. There will be some loss. And because of that loss, this difference of output minus input will not be equals to 0. In that case, we will find a solution such a way that this y1 plus y2 plus y3 minus x1 c1 minus x2 c2 minus x3 c3 should be approximately 0. And this formulation is nothing but based on least square solution, and we will target the output minus input should be equal to 0. When I'm telling output means y1 plus y2 plus y3. When we are telling input means x1 c1 plus x2 c2 plus x3 c3. So y1 plus y2 plus y3 minus x1 c1 minus x2 c2 minus x3 c3 should be minimum. And to formalize this problem, we will obtain the solution with the help of least square concept. So there are mathematical formulas which we can use it and we can solve it, but Python is very easy way it will solve this equation with the help of least square function, and with the help of command least square, and that will be available, or that this function will be present in the SciPy library function. So when we use the SciPy library, from the SciPy we can import the least square function, and then we can find the least square solution of given any or differences of output minus input. Let us consider, for an example, I want to find the least square solution of given equation y equals to 2 into x minus 3 whole square plus 1, as I was telling you, where y is the output and x is the input, and you wanted to give the, actually it should be equals, but approximately we need to find the differences, how much minimum that difference can be done, and this can be solved with the help of Python programming. So if you want to find the least square solution of given equation, any equation which we have considered y equals to 2 into x minus 3 whole square plus 1, so first we will import numpy as np. Everyone knows, if you want to plot it, then you can use matplot library function, as we have done already in the module 2, and then from SciPy optimize, we will import least square, LEST-SQ. See, my dear friend, LEST-SQ is the optimization function. I have given the introduction in module 2. The optimization means you need to optimize the difference. That's all. Output minus input difference we need to optimize. That means we need to make it minimum as much as possible, approximately to 0. But 0 cannot be done. That is the ideal solution which we assume, but practically that is not going to happen. So in that case, because it is an optimization algorithm, least square, LEST-SQ is least square is nothing but an optimization method which we will use to find the relation between output and input. And in that case, we will call it from SciPy optimize import least square, LEST. That's why we will write from SciPy dot optimize. SciPy is the library function, optimize is nothing but an object in the SciPy, which we will call it with SciPy dot optimize, because when we want to call the object of the function, library function, then we'll use the dot. Then SciPy dot optimize and import LEST-SQ, and from that we can find again which we want. First you need to define the function, so we will define the function f of x and then return the equation to whom you want to find the least square solution. So return 2 into x minus 3 whole square plus 1, and then we can find the least square of function. If you have defined that least square, LEST-SQ small bracket function comma 0 starting value is 0, and you will get the answer. So my dear friend, with the help of Python optimization function, we can find the least square of any given equation in the very simple and easy way. First, we need to import the least square from the SciPy optimize library function, because it is one of the optimization method which we will use it, and that will be present in the SciPy. So here we are not using NumPy, we will use SciPy. That is the advantage of SciPy. Through SciPy, we can use many optimization method. One of them which is there in your syllabus is nothing but least square. And I explained what is the concept of least square, what is the significance of least square, and how we can find the least square of given any equation. Thank you very much.